Good day, everyone. We are Group 3, and this time we will be talking about the petroleum refining industry. The petroleum refining industry changes crude oil into petroleum products for use as fuels for transportation, heating, paving roads, and generating electricity, and as feedstocks for making chemicals. The refining of crude petroleum owes its origin to the successful drilling first oil wells in Ontario, Canada in 1858 and in Pennsylvania, US in 1859. Before that time, petroleum was only available in small amounts from natural seepage in different areas around the world. The earliest refineries employed simple distillation unit stills to separate the various constituents of petroleum by heating the crude oil mixture in a vessel and condensing the resultant vapors into liquid fractions. Initially, the primary product was kerosene, which proved to be a more abundant, cleaner burning lamp oil of more consistent quality than whale oil or animal fat. By 1890, refineries were producing large quantities of kerosene and fuel oils. The development of the internal combustion engine in the later years of the 19th century created a small market for crude naphtha. During the 1930s and World War II, sophisticated refining processes involving the use of catalysts led to further improvements in the quality of transportation fuels and further increased their supply. These improved processes enabled the petroleum industry to meet the demands of high-performance combat aircraft and after the war, supply increasing quantities of transportation fuels. By 1970, the petroleum refining industry had become well established throughout the world. Delivery of crude oil to be refined into petroleum products had reached almost 2.3 billion tons per year, or 40 million barrels per day, with major concentrations of refineries in most developed countries. As the world became aware of the impact of industrial pollution on the environment, the petroleum refining industry was the primary focus for change. Refiners added hydrotreating to extract sulfur compounds from their products and began to generate large quantities of elemental sulfur.
Due to the new International Maritime Organization's low sulfur shipping fuel specification that came into effect in January 2020, the refining industry is undergoing transition. Currently, the biggest petroleum refining companies are China Petroleum and Chemical, China National Petroleum Corporation, ExxonMobil, and Saudi Aramco. China Petroleum and Chemical is among the largest oil refining, gas, and petrochemical companies in the world. They are a subsidiary of the China Petrochemical Corporation. The integrated energy and chemical company owns 30 refineries and employs 402,000 people. The key products of the company include asphalt, chemical feedstock, diesel, fuel oil, gasoline, LPG, jet fuel, solvent oil, kerosene, petroleum coke, and paraffin. Meanwhile, the China National Petroleum Corporation is engaged in oil production, exploration, development, and sales. The company had 11 refineries and 7 integrated refining petrochemical complexes by the end of 2019. They currently hold assets in 35 countries including Africa, Central Asia, Russia, America, the Middle East, Asia Pacific, and other regions. The company operates 26 refineries and petrochemical units, primarily in Northeast and Northwest China. Key products of the company include crude oil, natural gas, ammonia, diesel, kerosene, gasoline, fuel oil, lube oil, petroleum coke, and LPG. ExxonMobil are a global petroleum and petrochemical business. Their company explores, produces, trades, transports, and sells oil and natural gas. They are also involved in electrical power generation through coal and mineral operation. Among the many products that ExxonMobil sells are fuels, lubricants, and other petroleum-derived chemicals. They are the second largest oil company in the world by market value, despite being a small company. They operate across America, Europe, Asia Pacific, Africa, and the Middle East region. The key offerings of the company include gasoline, heating oil, kerosene, diesel, aviation fuel, heavy fuel, and specialty petroleum products. Saudi Aramco. They are one of the largest companies in the world across all industries, as well as among the largest global oil companies by revenue, as they are a major player in the oil industry. A list in the biggest oil companies would not make sense without including it. The COVID-19 crisis resulted in a 33% decrease in revenue in the first 9 months of the 2020 over the same period in 2019, driven by the lower crude oil prices and sales volume as well as the reduced refining and chemicals margin. The company, however, showed recovery in the global energy market due to eased COVID-19 restrictions in multiple locations worldwide. Locally, the big three still dominate the Philippine fuel market, namely Petron, Shell, and Chevron. The Petron Corporation is the number one fuel and oil company in the Philippines with a market share of 27.08% as of 2018. In addition to being the most significant domestic fuel and oil company, Petron Corporation also recently established operations in Malaysia after acquiring ExxonMobil's downstream business in 2012. In the Philippines, Petron supplies more Filipinos than any other fuel brand thanks to its operations of its 180,000 barrel per day oil refinery located in Bataan. In addition to this, Petron also has the largest market in service stations with more than 2,400 of them nationwide. Shell Petroleum Corporation is the second biggest fuel and oil company in the Philippines with a market share of 18.5% as of 2018. The company consists of more than 1,000 service stations nationwide where it sells such fuels such as Shell V-Power, Shell Fuel Save, and in addition to fuels, Shell also sells a wide variety of oil and lubricants including Shell Helix and Shell motorcycle engine oils and Shell truck and heavy-duty engine oils. And finally, Chevron, or commonly called Caltex, is the third biggest oil company in the Philippines with a 2018 market share of 17.86%. The company has almost 700 service stations nationwide and 20 major supply facilities including their main supply hub which is located at their terminal in San Pascual, Batangas.
Good day. Today I will be discussing the products for the petroleum refining industry. So first is gasoline. This is commonly used for vehicles that is made up of crude oil and different petroleum liquids. As you can see here, this is a distillation column wherein gasoline is created. So from this distillation column, it can also create types of diesel as well as kerosene. This is possible because of the different columns that has different heats, which is why it creates different types of fuels. That is why there is only one source when it comes to creating such oil. Moving on, gasoline can be categorized by its grade from regular to premium. As you can see here in the picture, this is commonly seen in gasoline stations, which is why you need to pay a higher price because the higher price it is, the better it is from resisting to ignite since gasoline is highly flammable so that it would not cause for the engine to combust. Next would be the kerosene. This is also made up of crude oil and also involves distillation as I said earlier. It is also highly flammable, usually used in different types of planes and serves as a cleaning agent as well. One problem, however, is that it produces carbon black, which is a type of ash that is harmful to humans when inhaled, which is why people are still trying to find innovations as to what can be replaced as kerosene. Here in this picture, you can see how it is being used for aviation. Next would be fuel oil. The same process, this is created from distillation columns, but its main difference is that it is stronger than kerosene and gasoline, which is why it requires more heat. This can be identified by the number or how much energy it powers engines. So firstly, here is fuel oil D2. This requires higher volatility because this is used in order for the cars to run in various different speeds. Next is for the fuel oil D3. This is used for trucks that has bigger engines and requires to maintain its speeds in order for the engine to last. So here's the type of automobiles as I said earlier like trucks and cars. There is no picture but for number 4 which is called a medium fuel oil. These are usually used for burner installations for homes and even sauna. So for number D5 and number D6, these are usually used for navies as they require heavy gas or mixing together, which is why as you can see here in the first picture, it is much more dark and because this involves somewhat a combination of using from the previous fuel oil. These are more commonly known as furnace fuel oil, especially used in the navy. You can see here, this powers different ships and even here the furnace.
So this is the process flow diagrams for the three major products of the petroleum industry. So this is an oil and natural gas processing overview that shows where crude oil is prepared, wherein it's separated from gas and oil and sent to refineries and gas processing plants, and then transferred through trucks, tankers, pipelines, and sent to other utility companies and LPG fractioners, petrochemical plant, which will then be sent to a plastic converter, and then further processing, which will reach domestic use and other products such as this. So the first main product is the kerosene. The raw materials is petroleum. Kerosene is extracted from a mixture of petroleum chemicals found deep within the earth, and these mixtures consist of oil, rocks, water, and other contaminants in subterranean reservoir made of porous layers of sandstone and carbonate rock. And over tens of millions of years, this organic residue was converted to petroleum by a pair of complex chemical processes known as diagenesis and catagenesis. Catagenesis, and the combination of these complex reactions creates the hydrocarbon mixture known as petroleum. And the process includes in the crude oil recovery, the first step is to collect the crude oil. Then, when any of the drilling processes break into underground reservoir, a geyser erupts as dissolved hydrocarbon gases push the crude oil to the surface. These gases will force about 20% of the oil out of the well, and water is then pumped into the well to flush more of the oil out. Then, after the oil is collected, gross contaminants such as gases, water, and dirt are removed. Desalting is one cleansing operation that can be performed both in the oil field and at the refinery site. The next is the separation. This includes distillation, as one of type of separation process involves heating the crude oil to separate its components. In this process, the stream of oil is pumped into the bottom of the distillation column, where it is heated. The lighter hydrocarbon components in the mixture rise to the top of the column, and most of the high boiling point fractions are left at the bottom. At the top of the column, these lighter vapors reach the condenser, which cools them and returns them to a liquid state. Then, the condensed liquid fractions can be collected separately. The fraction that is collected between 302 Fahrenheit and 482 Fahrenheit, or 150 to 250 degrees Celsius, is kerosene. The next is the purification. So once the oil has been distilled into its fraction, further processing in a series of chemical reactors is necessary to create kerosene. And catalytic reforming, alkylation, catalytic cracking, and hydroprocessing are four of the major processing techniques used in the conversion of kerosene. These reactions are once used to control the carbon chain distribution by adding or removing carbon atoms from the hydrocarbon backbone. And once the kerosene has been reacted, additional extraction is required to remove secondary contaminants that can affect the oil's burning property. Aromatic compounds, which are carbon ring structures such as benzene, are one class of contaminant that must be removed. Then lastly is storage and packaging. After extraction is complete, the refined kerosene is stored in tanks for shipping. It is delivered by tank trucks to facilities where the kerosene is packaged for commercial use. Industrial kerosene is stored in large metal tanks, but it may be packaged in small quantities for commercial use. Metal containers may be used because kerosene is not a gas and does not require pressurized storage vessels. However, its flammability dictates that it must be handled as a hazardous. Then lastly, the byproducts are lubricating oil and paraffin. Some portion of the remaining petroleum fractions that cannot be converted to kerosene may be used in other applications as lubricating oil. In addition, some of the contaminants extracted during the purification process can be used commercially. This includes certain aromatic compounds such as paraffin. So the next main product is the gasoline, and its raw material again is petroleum. Gasoline is one of the products derived from distilling and refining petroleum. Compounds of organic lead were added to gasoline in the past to reduce knocking in engines, but due to environmental concerns, this is no longer common. Other chemicals are also added to gasoline to further stabilize it and improve its color and smell in the process called sweetening. So the processes involved are exploration. The first step in the manufacture of gasoline is to find its parent ingredient, petroleum, just like what I said earlier. And after a possible oil reservoir is found, the area must be test drilled. Core samples are taken from test wells to confirm rock formations, and the samples are chemically analyzed in order to determine if more drilling is justified. Then the drilling commences. Crude oil is recovered through wells that can reach over 1,000 feet or 305 meters into the rocks. Then the recovery. To recover the oil, a complicated system of pipes and valving is installed directly into the drilling well. The natural pressure of the reservoir rock brings the oil out of the well and into the pipe. Secondary recovery methods are now required to obtain a greater percentage of the oil. Then crude oil is not a good fuel. So since it's not fluid that requires a very high temperature to burn, the long chains of molecules in crude oil must be separated from the smaller chains of refined fuels, including gasoline in a petroleum refinery. This process is called fractional distillation. And fractional distillation itself does not produce gasoline from crude oil. It just removes the gasoline from other compounds in crude oil. Further refining processes are now used to improve the quality of it. And next, catalytic cracking is one of the most important processes in oil refining because this process uses a catalyst at high temperature and increased pressure to affect chemical changes in petroleum. Catalysts such as aluminum, platinum, processed clay, and acids are added to petroleum to break down larger molecules so that it will possess the desired compounds of gasoline. Then additives are added. Once gasoline is refined, chemicals are added. Some are anti-knock compounds which react with the chemicals in gasoline that burn too quickly to prevent engine knock. And lastly, gasoline is primarily a mixture of two volatile liquids, heptane and isooctane. Pure heptane, a lighter fuel, burns so quickly that it produces a great amount of knocking in an engine. Pure isooctane evaporates slowly and produces virtually no knocking. The ratio of heptane to isooctane is measured by the octane rating. The greater the percentage of isooctane, the less knocking, and the higher the octane rating. For example, an octane rating of 87 is comparable to a mixture of 87% isooctane and 13% heptane. And lastly, the byproducts are lubricants, plastics, and asphalt. On average, 44.4% only of petroleum becomes gasoline. There really are no waste products from petroleum. The lighter chemicals are natural gas, liquefied petroleum gas, LPG, jet fuel, and kerosene. The heavier products are used for manufacture of lubricants, plastics, and asphalts. And in addition, many less valuable products can be chemically converted into more saleable compounds.
The total amount of petroleum in a reservoir is called oil in place. Many petroleum liquids that make up a reservoir's oil in place are unable to be extracted as it may be too difficult, dangerous, or expensive to drill. The part of a reservoir's oil in place that can be extracted and refined are called reservoir's oil reserves. These figures show the regional breakdown for oil production and consumption from 1994 to 2019. As seen from the chart, the Middle East is the region with the highest oil production per day from the overall oil produced daily in 2019 and from the past few years. While, for the oil consumption, Asia Pacific is seen to be the largest consumers of oil daily in 2019, wherein overall global oil consumption grew for about 0.9 billion barrels per day, which is led by China where demand rose by 680,000 barrels per day, the largest increase in the country's demand since 2015. By product, consumption growth was led by ethane and LPG at 380,000 barrels per day. According to the U.S. Energy Information Administration, the global petroleum and other liquids, the total world production is about 100.66 million barrels per day in 2019, which is forecasted to be about 101.82 million barrels per day by 2022, while the total world consumption in 2019 was recorded to be about 100.90 million barrels per day and is forecasted to be about 101.31 million barrels per day in the year 2022. This map shows areas that are in service contract that are shaded in red. This represents areas where industries explore and develop oil or natural gas field. Roughly, only 10% of the country's territory has viable data in relation to petroleum exploration, with the data heavily concentrated in the offshore western side of Palawan and onshore Cebu. As of 2016, the Philippines holds 138.5 million barrels of proven oil reserves, ranking 64th in the world, accounting for only about 0.01% of the world's total oil reserves of 1,650 billion barrels, making the Philippines highly dependent on oil imports in order to sustain its consumption levels. For the Philippines importation, the product import mix comprised mostly of diesel oil at 42.2% and gasoline at 19.4%, and are followed by LPG, kerosene, fuel oil, and other products at 8.9% share in the total product mix. In the first half of the year 2019, the total product import to the Philippines accounts for 65.5% of the total product demand, wherein the total gasoline import reached to 52% of gasoline demand, while diesel oil import was 65.3% of diesel demand. LPG, on the other hand, was 81.3% of LPG demand. While for the Philippines exportation, the total export mix comprised of several petroleum products, wherein the top four are condensate by 40.6%, Pygas by 4.3%, naphtha by 8.8%, and mixed C4 by 8.1%. These are then followed by fuel oil, gasoline, propylene, mixed xylene, diesel, asphalts, toluene, benzene, reformate, and lastly, LPG that accounts for only 0.02%.
I'm going to discuss about top producing countries and petrol refining. This table data is from the International Energy Statistics, Independent Statistics and Analysis. It shows the 10 largest oil producers and the share of total world production 2020. The production includes domestic production of crude oil, all other petroleum liquids, biofuels, and refinery processing gain. As you can see, the United States is the top oil producing country with an average of 18.6 million barrels per day and accounts for 20% of the world's total production, and one of the biggest refiners in the world, having approximately 19 million barrels per day and 18.8% of the world's total refinery capacity. Saudi Arabia produces 11 million barrels per day and accounts for 12% of the world's production. Russia has an average production of 10.5 million barrels per day and accounts for 11% of the world's production. It also has the refinery capacity to produce 6.5 million barrels per day. Canada produces about 5.3 million barrels per day and accounts for 6% of the world's total production. China has an average production of 4.93 million barrels per day and accounts for 5% of the world's production.
and has the second biggest oil refining capacity in the world with 17.5 million barrels per day. This is the end of our group's video report about petroleum refining. Thank you for listening and we hope that you have learned something. Keep safe everyone.